Once upon a time, not so long ago, in fact last week actually, there was a gamepad called Gary. Gary decided to Google himself. Gary found out lots of interesting information about himself. But Gary had a heart, and it seemed as if people neglected that fact. Everybody seemed to know how to tickle his thumbs and press his buttons. But what about his heart? Two little motors that were crying out to be used. Then by chance Gary discovered a book series. Unity Adventures with Uncle Chaucy. And to Gary's surprise there was a book dedicated to making Gary's heart move to the rhythm of some music. Gary was a happy little gamepad. Now he could dance his little heart out to some banging tunes.
Poor little Gary. Let's see what we can do to make his dreams come true. So if we jump into our core Audio Manager scripts folder, we'll create a new C# script. And we call this Audio Rumble. Okay, once that's finished compiling, we'll open it up in Visual Studio. I'll just get rid of those because we won't need them. Okay, so our first set of variables we're going to need is we're going to need two actions. You'll notice it's come up red, so we're going to do using system. These are very similar to the Unity events we used in the last episode. So we're going to have our first action will be public static action, and then we're going to pass a sound effects clip to it. We call that update clip data, and we set that equal to a method that we haven't created yet called setup clip data. And then we've just got a static action to reset the clip data, which we'll call a function called reset clip. Okay, next we're going to need some clamping values, so we'll have two serialized fields, private floats. If you want to make them public, you can make them public, but there's no need to. The min value would be 0 and the max value would be 1. You can change these clamping values if you want to scale light, scale objects, flashlights or anything. You can basically use the same code that we're using now, apart from we won't divide the sample data by the amount of samples to give us a smaller value. Because we're using a gamepad, we only want to go between 0 and 1. Okay, so our next lot of variables. Okay, we're going to have a private static float current update time, and we're going to set that to 0. Then we're going to have a private static float array called clip sample data, and we'll default that to null. Then we've just got two private floats, one for clip loudness and one for cached data. Okay. And the final three variables will be we need a private static SFX clip, and we're going to call that clip data. We need a audio source, and we need gamepad. So we need to be using the new input system for Unity. Okay, so if you want to have a quick pause there, we've got our two actions that we're going to use to update and reset this script. We've got our clamping values, we've got a float for update time, we've got an array for sample data, we've got a couple of floats for the loudness and cache data, we've got a link to our SFX clip, one for our audio source, and then our gamepad. Okay, so Unity base methods. Let me get rid of those. Okay, we're going to use some shorthand. So we're going to have private void on enable, and then the equals greater than sign. Then we're going to do gamepad equals gamepad.current. This just saves us wrapping it into brackets. We can call methods direct just by using this little operation here. So on disable, we're going to reset the clip. And on update, we're going to do a check rumble function. So let's jump down into our user methods. I'll scroll that, leave that there for a second, just so you can type that out. Okay, so we do the check rumble method first. First thing we're going to do in this method is, if the clip data is null, we're just going to return. If the clip data isn't null, we're going to check if clip data use rumble is set to true, which, if you remember, is the boolean in the scriptable object that we've got for use rumble. And then we're just going to check that the sample data is not equal to null. And if we're good there, we're going to apply the clip data. Okay. I hope that's self-explanatory. Okay, here's our apply clip data method. First thing we do is we're going to update our current update time. So current update time plus equals time.delta time. And then we're going to check if our current update time is greater than our update step, which is again set in our scriptable object. If so, the float value cache data that we got up there, we're going to set that to the clip data sample that we're going to grab in a minute from this get clip data method. And then a final sanity check. If the gamepad is not equal to null, we're going to set gamepad rumble, and we're going to set the low frequency and high frequency, or left and right motors, to the cache data value where we got the clip data from. Again, I hope that's pretty self-explanatory. Okay, so now the get clip data function. This is the meat and potatoes of it. So first thing we're going to do is we're going to set our current update time back to 0. Then we're going to grab our audio source .clip.getData. So this is going to get the data from the clip that the audio source contains. And get data wants a float array and an amount of time samples. So we're going to use our sample data for the array, which we created back up here. And we're going to use the audio source.time samples. As you can see, it's the playback position. So we grab that current data there. Then we're going to set the clip loudness to 0. Then we're going to loop through each sample in the array, and then set the clip loudness to mathf absolute, and then the sample value. Next thing we're going to do is we're going to divide the clip loudness by the clip data.samples. This will give us a small number because we only really want a number between maximum of 0 and 1. If you want to scale objects with flashlights, you would basically leave this line out. Everything else would be the same, getting the data, and instead of passing it to the gamepad, we'd end up actually passing it to the game object you're scaling, or the light, the intensity that you're flashing. So we're going to divide our clip loudness by the amount of samples we've taken. But they're going to multiply our clip loudness by the amplitude. And finally, we're going to clamp our clip loudness between the min value and max value. So that's 0 and 1. And then we're going to return the clip loudness. That result will be passed into this cache data. And then that cache data will be used to run the joypads. Okay, if I just leave that there for a second so you can pause and get that typed out. Hope that made sense. Rather than going in to all these crazy algorithms, this was the easiest way that I found to get some form of response to your gamepad. Okay. Okay, next we're going to have a static method this time. So private static void setup clip data, and that's going to take the sound effects clip. If you remember up in our action, it's going to require a sound effects clip. So we're going to set the clip data to the clip. The audio source we're going to get from the clip data audio group audio source. And then the sample data we're going to pass in and create a new float array for the amount of samples we set in our scriptable object. So that's all there is for the setup clip data. Now we want to reset the clip. So again, this would be a static method. So private static void reset clip. If you're wondering why these are static, it's because our actions are static. These need to be static. We don't need them public because they're just being called every time we send the event. So all we're going to do in this reset clip is we're going to set the clip data to null, the clip sample data to null, reset the current update time, and then if we have got a gamepad connected, we're going to just set the motor speeds to 0 and 0. Then finally, all that's left to do is actually set the gamepad motor speeds. Okay, so we've got private void, set gamepad rumble is the name of the method, and we've got two floats, one for motor left and one for motor right. And all we've got in there is simply gamepad.set motor speeds, and then we're going to set the left motor, low frequency motor here, and the right motor here. So that is literally all we need for the script. So let's just quickly run back up here again. So we've got our two static actions. We've got our update clip data and our reset clip data. That's going to take a sound effects clip. We've got our clamping ranges 0 to 1 because we're using the gamepad, and the motor value can only go between 0 and 1. We've got these two static floats, one for current update time, and then this float array for our sample data. Two just normal private floats for clip loudness and cache data. Then we've got a private static sound effects clip called clip data. We've got a private static audio source called audio source, and a private static gamepad reference called gamepad. On enable, we're just going to set gamepad to the gamepad.current. On disable, we're just going to reset the clip data. And on update, we're just going to check rumble. In check rumble, first thing we do is we check if the clip data is null, then we're going to return. If it has got some clip data, we're going to check if we want to use rumble. And also we're going to check if the sample data isn't null. If it passes both of those checks, we're going to do the apply clip data method. So we're just going to increment the time, and then if the time is greater than our time set for updating in the scriptable object, we're going to grab the sample clip data, and then we're going to set the gamepad rumble to that value of data. Okay, so we can now save that, jump back up into Unity. That should get rid of all of our errors. I will drag that onto there. So now we need to go to our audio event test script. And right at the very, very top here under audio clips, we can now uncomment the sound effects heartbeat clip. Okay, in the play audio method, again, we only got this event ball because we're permanently sending this in update. All you need to do is set our heartbeat to the secondary audio event. If you remember, we had a primary and secondary audio event. The primary was just a play one shot event. The secondary is play, so it's like a playing music event. We're going to use that. And then we can uncomment the audio rumble update clip data, and then we're going to pass the heartbeat clip in. And then now we just need to go down to the stop. So we need to, when we finished, raise a stop audio event and finally reset the clip data. That should be all we need for our audio event test. So once again, this event is purely because we're doing it in update as a sample. You're only ever interested in raising the primary audio and secondary audio events and the stop events. Okay, with that done and saved, we can now jump back into Unity. And now we've got a heartbeat clip come up. We go to our sound effects clip. We duplicate that. We set the sound to heartbeat. We're going to check use rumble because we want to use rumble on this sound effects clip. For this clip, 120 should be fine, amplitude of 1 should be fine, and update step should be fine. So we can now drag that over. Let me get a joypad near my microphone, so we can actually hopefully hear some rumble. Now if we click play, and you can hear the gamepad rumbling away. Let me just drop the amplitude of that a minute. Where's my audio manager? I've turned the master volume up so you can hear the sound effects a little bit more. But set amplitude back to 1. And as you can hear, the gamepad is vibrating along to the audio clip. Okay. This can be done with these music clips as well. You can just check use rumble, but we're going to look at that when we start creating our jukebox in the next video. If you haven't used my audio manager, I can't remember now, although this video isn't that long, my memory is like a goldfish. So if you're not using my audio manager, you can get audio rumble script from the description in this video. It's not going to be the same as this. It'll have a spot for an audio clip that you can put in yourself. So that's how we can get some ambience added to our game via some feedback, either via thunder, heartbeat, or any sort of stuff like that. Explosions, you can add a bit of rumble to your sound effects and your gamepad. Hope you found this video useful. As usual, being a Cedarwood software video, it's a total mess, but there you go, can't be helped. I will see you in the next video.